Okay, we're going through the next part from my book, Prevent and Reverse Diabetes. I think this is like part 8 or something. We're on page 78 of the book. Also, by the way, if you like these reviews, please write a review on Amazon. You can say the book's a piece of crap and it sucks if you want, but it's better that some review than no review. Also, if you want to see my best video on diabetes, I think my best lecture is probably the one over at VegSource just about a month ago on diabetes. I've given a whole bunch of other. I got a whole playlist on diabetes. And I've given good ones over at Be Green with Amy and Chef AJ and whatnot. Anyways, let's get going here. We're going to talk about complications of diabetes. This is some rather advanced stuff, but just to know, this is what happens to diabetes. A whole bunch of bad things happen. Once you got saturated fat inhibiting the inner mitochondrial membrane electron transport, you got a backup of Krebs cycle, a backup of glycolysis. In particular, you get inhibition of this enzyme right here, right in the middle of glycolysis. Glycolysis hits a transition point where it goes from 6 carbon sugars like glucose and fructose going into the 3 carbon sugars. Okay, and the bottleneck is glyceraldehyde 3-phosphate. Okay, and that enzyme is glyceraldehyde 3-phosphate dehydrogenase. All right, whenever there's a dehydrogenase, you know there's like an NADH involved. All right, so what happens is there's something called PARP. It's like polyadenylated ribosylating protein, and the relevance of PARP is it's actually a DNA repair enzyme. Glyceraldehyde 3-phosphate dehydrogenase moves around from the cytoplasm to the nucleus, and then the DNA repair enzyme in the nucleus, PARP, damages glyceraldehyde 3-phosphate dehydrogenase. Once that's damaged, the substrate, glyceraldehyde 3-phosphate, backs up, and then it starts going into side products. In particular, it goes into MGO, methyl glyoxyl. That then produces advanced glycation end products, binding to other molecules and damaging them, damaging their structure so they become non-functional. And you'll hear about that all the time, AGEs, advanced glycation end products, irreversible binding. It'll also pass into something called the PKC pathway, including diacylglycerol. So instead of a triglyceride, a diacylglyceride, a diglyceride. But anyways, that's going to activate this protein kinase C pathway, and that's a disaster. I'll show you what that leads to in a moment. There's some other pathways activated, not as important for our purposes, like the polyol pathway, the hexosamine pathway. These are all complications of diabetes. And where does this information come from? In particular, from the Michael Brownlee paper. He won the Banting Award in 2004, Unifying Theory of Diabetes Complications. It's a magnificent paper, okay? All right, so now we're going to show some of these things. What is really going on here? Okay, so here's more detail about the advanced glycation end products. Once glyceraldehyde 3-phosphate dehydrogenase goes into MGO, it just creates a disaster. MGO glycates proteins inside the cell and damages them in the cell cytoplasm. MGO then passes out into the extracellular space, and it damages proteins too. It's got 2 ketones on it, MGO. It will then glycate things like collagen in the extracellular space. It'll get into the blood, glycate albumin, for example. And so the advanced glycation end product is taken up by a receptor like on a macrophage, and it'll be called the RAGE, receptor for advanced glycation end product. Sounds like the RAGE receptor. Okay, and that'll cause more inflammation. It gets almost like a vicious cycle going, and it increases nuclear factor kappa B, which is like a transcription factor to produce more inflammatory cytokines. So the bottom line is it's all bad. It's like the SHIT hits the fan. Okay, so I'm letting you know these are the consequences of diabetes. That's why just when somebody says, oh, my numbers are okay, my blood sugar's okay, they don't understand all this stuff is happening in the background, and you don't want this stuff to happen. Okay, here's just a little more information about what's an advanced glycation end product. It's irreversible binding of the side chain of a sugar-like molecule with a carbonyl group to a nitrogen side group on, let's say, a lysine of a protein. Okay, and then it forms an irreversible bond. That's why it's called an end product. Okay, and it'll stiffen the collagen, so the collagen's not as functional as it should be. It'll also, the hemoglobin A1C in the red blood cells gets glycated as well. Glucose in particular will glycate that. But I'm just showing you, here's hemoglobin A1C. Normally you'd want it at least less than 5.5. 5.5 to 6.5 is pre-diabetes. Over 6.5 is diabetes. Okay, so it's going to stiffen the RBCs as well. All of this stuff is bad. It's an indicator over a course of 3 months, 120 days, because red blood cells live 120 days of glycation and blood glucose levels. Here's some more of the things that happen. This is that protein kinase C pathway that got activated from the substrate, glyceraldehyde 3-phosphate dehydrogenase in the cytoplasm of glycolysis, now getting converted to diacylglycerol, and then this whole protein kinase C pathway activated. So it's going to inhibit endothelial nitric oxide synthase. So you can't make nitric oxide your vasodilator. Instead, you're going to make endothelin, which does the opposite of nitric oxide. It's prothrombotic. It causes platelet stickiness, platelet aggregation. So it increases your tendency to form blood clots. It prevents vasodilation, so it leads to vasoconstriction. And this happens especially in the small vessels, like in your foot. That's why diabetics get all these amputations. It also blocks something called plasminogen activator. It inhibits that, so you get less fibrinolysis, less ability to dissolve a blood clot. Okay? And then in the eyeball, you get increased activation of vascular endothelial growth factor, which causes the ingrowth of blood vessels on the back of the eye, which decreases vision. Okay? So you get a diabetic retinopathy. This is diabetic microvasculopathy. Okay, and then we talked about nuclear factor kappa B being increased by the advanced glycation end products, and this relates to it as well. You get increased activation also of NADPH oxidase, more reactive oxygen species, oxidative stress. Oxidative stress just means you got more oxidants than antioxidants, okay? Electron stealers, causers of chain reactions. So it's all bad. That's why diabetics, they really should get their act together as fast as they can, become low-fat vegans with no oil, because the more time is going to go by, they're going to lose their ability to make insulin in their pancreas, and then they're stuck being on insulin dependence for the rest of their life. Okay, here's a lecture I want you to know about. This is the Banting lecture of Gerald Sheldman. This guy's a genius. He was part of the group. He was working with Roy Taylor over at Yale, and they figured out that the accumulation of fat in the skeletal muscle, they call it intramyocellular lipid, was the first detectable confirmed finding of insulin resistance. So it's a fat disease, okay? That's important to know. Sugar is a side effect. It's a fat accumulation disease in skeletal muscle. And this lecture is available online. You just type in his name, Gerald Sheldman, Banting 2018 lecture. It's a magnificent lecture. And, he talks about the ectopic fat theory of diabetes, okay? And it all makes sense, and it's beautiful. If you want to see that, it's available on YouTube. Okay, the next guy I want to tell you about is Roy Taylor. He won the Banting Award in 2012. He's the guy who figured out that if you could just reverse fatty liver, you could cure diabetics. If they had it less than 4 years, you could cure almost all of them. And that's assuming they have type 2 diabetes. There's a subset of diabetes called LADA diabetes, latent adult diabetes, autoimmune. And I'll talk about it in a separate paper. But the bottom line is you don't sometimes initially know if the patient is type 2 or if they're type 1.5, LADA. Okay, but what Roy Taylor showed with MRI, where you could see the fat percentage in the liver diminishing when the patients lose weight. If they could lose 30 pounds or more, all of his 4 years or less diabetics were 100% cured, type 2 diabetics, okay? He wrote a nice book, too. His book was called, we'll come to it in one sec. So if you lose 30 pounds, you get good normal blood glucose levels. Diabetes goes away. This was his book, Life Without Diabetes by Roy Taylor. And he basically said, diabetes is a disease of fat excess. If you reduce the amount of body fat, you can cure all of the type 2 diabetics. That's assuming that their pancreas is still functioning and that they're not 1.5 diabetics who've lost much of their pancreatic function. If you go to YouTube, you can find lectures by him as well. They're very good. The only thing is, his diet to me seemed like a short-term solution. He would give the patient, these nutrition shakes, and they'd have to only have something like that, a very limited meal, to get them to lose the weight kind of fast. But what you really want to do is you want to win the game for life, long term. So you got to eat something sustainable, and the best way to go with that is low fat, low sodium, 100% vegan, low protein too, no oil, no caffeine, no sweets. Anyways, hope you found that helpful. We're going to stop there for today.